If I look at this next one, again, the first thing I want to do is have it set equal to 0, just so I can test to see if this thing can be factored. And then if it can, I'll go from there. So that's going to give me an x squared plus 3x minus 4. And really, this one's not a good candidate for completing the square anyway, so we want the whole thing set equal to 0. So that allows us to check for factoring, and then if that doesn't work, we'll go to our quadratic formula. So I build a bridge, that gives me a -4. The two numbers are going to be a 4 and a -1, so this one is going to factor. And I can use my shortcut, that's x plus 4 and an x minus 1. And now from here I can set each factor equal to 0. And now I solve each, so this one I subtract the 4 from each side. That's going to give me x equals a -4. The next one I'm going to add the 1 to each side, and that's going to give me, I don't know why I wrote an 8 like a crazy person. Let me try that again. So that's going to give me x equals 1. So my two answers here are the -4 and the +1. Okay? If I look at the next one, it looks like it might be a little bit of a pain, but the only reason it looks that way, this is actually a relatively simple one, but it looks difficult because of that 1/2 out front. So just like any other equation we've ever approached, if we want to get rid of fractions, all we have to do is multiply everything by the common denominator. So I'm going to multiply each side by 2, and what happens, that leaves me with an x squared plus 4x plus 4 equals 0. And I'm allowed to just multiply by 2 because it's an equation. I can keep it balanced by doing the same thing to the other side. Now I would probably build a bridge. So I'm looking for two numbers that multiply to a 4 but add to 4, and that's a 2 and a 2. So this factors into an x plus 2 and an x plus 2. And now I would set each factor equal to 0, so I would do the x plus 2 equals 0. Do I need to bother rewriting the x plus 2 equals 0 again? And the answer is no. Obviously, that's going to give me the same answer. So I'm going to get the same answer twice, which is fine. I only need to write it once, though. I subtract that 2, and I find out that x equals a -2. This is a special case where the solution, the x-intercept, is actually also my vertex because it's just touching at one spot on the x-axis. Okay? And then this last one, because it's already set up for my square root property, I'm just going to take the square root of each side. And the only caution here is when I take the square root of each side, I just have to remember that I have to do plus or minus whatever this thing is. And the square root of 25 is actually a 5. So it's plus or minus 5. So there's actually two answers there, the +5 and the -5. And if you're worried that you're going to forget about the plus or minus, remember the other option here is just to bring that 25 over. So if I had x squared equals 25, I could subtract the 25 over to the other side. And I'd get x squared minus 25 equals 0. And then I could solve this thing by factoring. This factors into an x plus 5 and an x minus 5. And you can kind of see where this is going to go from here. I'm going to set each factor equal to 0, and I'll still get those two answers, all right? So if you're worried about missing that plus or minus, just split it up and do factoring for these, okay? Hope that was helpful, and good luck on your test.